Hey, this is Steven from Legit Tech Tutorials and the Green Engineers. So, today we're going to be looking at our new series, the Laser CNC Laser Cutter, DIY CNC Laser Cutter, small, compact, very easy to kind of move around and store and all that stuff. So, basically, I'm going to kind of recap what I believe I said in the first video, which is basically that the machines coming out of China are too big. They have a stand. They take up way too much space. They have way too much room in the bottom. Why is there this much room here in the bottom? Why is this so long? Why isn't it just, why isn't it just very, very good at utilizing space, etc.? So what I wanted to set out to do is do a DIY laser. I did start my DIY mill, so we're going to see, because I did find a Tormach that I could possibly buy. So we'll see if I have the time, and soon I'm going to be full-time, so working, so I don't know if I'm going to have time to build it. So in the meantime, I have some companies beating down my door to make parts, so I might just buy a Tormach, and build that on the side. But this one, I do not have the need, somebody beating down my door to build this, so I have a little bit more time to build this machine. So I don't know if you guys remember, but basically I have this 8-foot long cabinet that's 23 inches deep for this guy to fit on. Now that is kind of our limitation, and also the height of that cabinet is also the limitation. So we need to design something very, very well acclimated to fit in that area. Now the budget is about, and this is probably going to be all Arduino controlled, so just gerbil. It doesn't need to be something super advanced. It just needs to have be able to fire the laser at a certain frequency, and do all that kind of stuff. So it just needs to be able to do that, to be able to do raster vectoring and that kind of stuff. And again, this was for the EcoBase 3D printer project. So that's what this guy is for. So it's for one of my projects, to manufacture one of my projects. That project is kind of on the back burner, so it gives me some time to put this together, but this is the main component, plus not including a 3D printer that is required to build that machine. The EcoBase 3D printer, which is a bamboo framed 3D printer. So one of my buddies, the guy that has the 150 watt, the Tormach laser. He has, no, it's gotta be bigger than that. I think it's probably this one. How much is this? So he's got the 150 watt. So he's got a Boss laser. So let's see what this would be. He's got a 150 watt laser. I think he's got the 24 by 36, I think. He's got a couple lenses. He does have the water chiller. He does have the, I think he has the chuck rotary. I don't know where he's I guess he's exhausting out his building, because out his front glass. So here, that's 13 grand. So I think that's a pretty decent deal. I thought he was upwards of like 20 grand, but this does look a lot like his machine. This probably is the one that he has. Oh, maybe not. He's got a way better looking one than that. He's got this one then. Because he cut metal on it. Yeah, that's more like it. So he's probably got 20 grand into his. But obviously you could see kind of all of the stuff, all of the junk stuff that's not really required here. So let's show you guys some more. So this is kind of what he has. So that's, I could go there and look at it and make kind of some let me see. There's some more. So there's some on YouTube and stuff, and open builds and stuff like that. That you could look at for these here. Something like this. Let me stand by, find a good one. This is nice too. That one's also nice. So here is kind of what we're talking about here. This is kind of what we're talking about. So obviously I really do not like it when this happens, because now you take up all this extra space for this thing. Just put the electronics underneath. Chances are, even if the laser hits it, it's not going to do anything. So, or put it in the back where the tube is. I never know why they don't put it in the back where the tube is, underneath the tube, because the tube's not gonna fire a laser over the tube. So I really don't understand why they don't do that. Yeah, so, and then here he's using these. Okay, so what I'm thinking is maybe something, what, 120 by 80. So that's like 120 centimeter. Yeah, it's like that's like, I don't know, 15 inches or something. Here he's got his cooling. So yeah, so here he's using open build 2020 extrusion, which is exactly what I'm thinking. So this is kind of, and then he's using diamond plate, obviously a little excessive. He's using, this is another option, is he's using this controller, which I could do that. Which, this is a nice controller for, this is kind of the higher end of the controllers here. The DSP controller. But then you need all, all the electronics, and that's about $130 compared to a $30 Arduino kit gerbil. So that is an option. But what I do like is possibility of slowing down in corners and doing kind of more control inside something like as fusion expands and stuff like that, being able to control its movement more and just send it G-code rather than send it to this controller. So here, yeah, see, this is all wasted over here. So obviously we're not, that desk space is very crucial, so that I'm not gonna do that, absolutely. So here he's got that. Wow, that's a big area. Obviously we're not talking about something this big or this deep. Because again, how thick a material is he going to cut? Why does it have to be so deep? Oops. Stepper motors, yeah, just use stepper motors. I might upgrade to servos. Using O-Drive. So using O-Drive to do faster rasters. I would definitely like to do some faster rastering because most of my stuff on my project on EcoBase is a lot of it's rastering, a big portion of it's rastering. A lot of my extended, my extra price stuff options are the rastering. So eventually we'll step up to those types of stepper drivers, so I'm wondering if this would be able to handle that. I do like this interface, but I'm going to have a computer down there anyways, so I might as well have it. Here's some thermocouple stuff, it looks like. I might as well have something in there that I could do multiple things with. And here he's just got some stepper drivers here. So basically this would be 2 O drives. I don't know why he has a third one, because I don't really need it to do. I'll have to see if I need it to do Z, but if it's the Z, basically it could be a stepper driver. It doesn't need to be a servo. So each O drive could handle 2 servos. So basically we could have X, Y, and then have a stepper on the Z. And then just move the Z down and just level the build plate out, and then the build plate doesn't move. It's just that the nozzle gets further away, and then we just have a chip pan down here at the bottom that I could just pull out and get everything out, and then make the rest of this, just put all see-through acrylic all the way around, make it nice and light, and seal it in there, and then suck the material out of the back and send it through a HEPA filter and clean it out, and that's basically it. So that's kind of my plan. I really don't want to have the extra stage here, so if I have the laser back here, just have enough room for the table, probably a table at this size. Obviously I'm not talking building it this big, but the table, probably just level it out, so have it attach here, maybe have some sort of feet that go on the bottom and hold it up, some sort of metal feet that go on the bottom and hold it up, and then kind of level it there and get it all nice and level, and then just move the nozzle up and down. But then obviously if that was the case, I'm going to now have a stepper driver on there. Maybe I go with like a multi-turn servo. That would actually be preferred. So just run a multi-turn servo, which is extremely light, so then I don't have to worry about going back and forth, and then I don't have to worry about the leveling and have the motors down here and the linear rate and then the screws. So we'll look at that and see how light we could get, because really the stepper motor also here doesn't have to be that big. A stepper motor could be one of those tiny little geared ones, right? Because we're not talking about very extreme motion. It's just going to drop down, not even drop down that fast. It could be very, very slow. So it just could be one of those plastic geared stepper motors. So either a servo, and then if we have a servo, we get rid of the stepper driver altogether and just have an O drive with the 2 brushless motors on there that are zipping back and forth. So we could either do that, which we might as well, because the O drive can do both, can do 2 motors, or we just put the O drive on the X and then have a regular stepper on the Y, because the Y is just going to move. It doesn't have to spin very fast, because what I'll do is I'll just wipe on the X, back and forth on the X, not on the Y. I'll just pick an axis, either the X or the Y. I'm thinking just the X, because this is probably going to have more weight than just the laser. So probably just the X. I'll probably just have an O drive on the X, and then the Y will just have a regular stepper on it. And then if I wanted to later, I could upgrade it to a brushless. So hopefully at some point O drive has a cheaper version that just has 1 motor option. O drive robotics. $120. I just probably put a tiny little motor on it. It doesn't need to be a big motor. And then encoder. And then so this is like $100. So $100, $200. So then I could save another $100. I don't need it. I don't need a second. Motor, but it would be nice because these are 800 count per revolution. So versus a microstep, which is I believe. Let's say, what is that one? Microstepping. So yeah, 256. So yeah, 256 steps. So 256 times 200 steps per revolution. That's 51,000. This is still 81,000. So 81,092. I'm missing something. 8,192. So that's not as much if you could do the micro step. So let's say that one divided by 200. So you just need 40 microstep per step, basically 41. So technically the unless you get a higher count per revolution encoder, the stepper motor will be more accurate, right? So basically you could get higher fidelity with the stepper motor compared to these motors here. So on the Y it's probably a better idea. Maybe even on the X it'd be a better idea, but just go slower. Or gear it. Gear it for higher speed. So this guy's lower RPM but higher output speed. That would also work as well. So this is kind of a good idea on what I'm looking at building. Let's see if they have some other options here to look at. This is kind of another one. Again, a lot of wasted space here, but you could see kind of the plexiglass here. They are using some big extrusion, which would definitely help if moving the. Oh, he's using a diode laser. But yeah, this is nice. Oh, he's even got the Open Bills logo. Here's the load. He's got the nice controller on it. Where's the laser? Laser's in this side. There's a laser. Laser's underneath. Okay, so yeah, this should be in the back. I really don't know why they do that. Also, I'm curious if maybe even do a Core XY setup will help increase speed. So that's also something I'm curious about. Because then both in XY, so if it's only going across, back and forth in the X, if you have a Core XY, it's really going to help with, because I think both motors help with that, with the Core XY. Now this is another interesting thing. But, so basically I want to have enough room for the rotary as well. So be able to take the bed out basically and put the rotary in the bottom. Okay, so he's doing stepper driver, he's doing steppers for the table. With it, getting the table super square is gonna be difficult. And then here we do see the laser. Here is it outside the box. Oh, he's going in ascending order, it looks like. These are really nice high quality pictures though. So basically my plan is to have the laser back here and then have the electronics underneath it. And then just have the controller, if I do have a controller and not a gerbil or anything like that. Obviously if I do the controller I can't do core XY because it's just going to do XY. Is I could have it in the same spot there, but just have the wires go down and away from the laser, and then go underneath, travel against the side, and then back into the electronics, and have, you know, a little tilt up something where you could tilt it up and you look at the controller and then have it hit the run button on it and have it run without, you know, having to take up that whole side. So basically most of it's going to be used, only the spot where the laser tube is not going to be used. And I like this is nice. Temperatures and then amperage there. I was thinking, why don't they just replace these with Arduino, and so you could log it and then have a display here. That's probably what I would do, is have a separate Arduino that would do these or something, and then it would look at max milliamp here and track that, or like a rolling average or something like that. So you could use O-Drive off of these, but I need to see if I could get a better resolution off the O-Drive. Obviously, another thing that you could do is you could make it so that the pulleys are very, very small. Obviously, I'm going to use belts. Pulleys are very, very small, and so you get lower distance traveled per rotation. But I think already that this will go past the actual laser size. So in the 150 watt laser that my buddy has, it's got like a 5 millimeter focused beam. When it's focused, I mean it's like 5 thou. It's like 5 thou thick. So if you do better than 5 thou, let's see here. So let's say you have 16. So here's E3D, this website. So you have here a 16 tooth pulley. We have 19.4 millimeters. Sorry, 9.4. And that's diameter. So that's about a little bit over 3/8. So what we're going to do with that is times 2. Sorry, so basically that times pi, pretty much. Where's pi on this one? Okay, so each rotation is 1.16 inches on the GT2 pulley belt. So let's divide that by this number, 8,192. 8,192. So basically, if I wanted to visualize that, so that is 1, 2, so from in front of the 4 over 1, so that's 3, so 3 digits. So that's 1, 2, 3, 4. Right, so basically that's 1/10. So 0.0001485. So that's already smaller than the laser size itself. So really we could go with the O drive because there's no point in having increments smaller than that, because you're not even going to be able to see the fidelity because you don't have the dot size. So basically you can only do PPI, pixels per inch, and pixel density, I guess you could say. So in this case, most pixels are square. In this case, we have a round pixel. So 0.005 0.005 times 0.005, right? Because basically 5 across 5. It's a diameter, so obviously you have a little bit of a kind of a missing there, but that's okay. So that's about the area per pixel, quote unquote. So let's just say 1 divided by 0.00. Okay, so let's see. So this is just looking at an idea. So let's say let's go over here to Samsung's website and let's look at their brand new phone, the S10e, I guess, or S510. Yeah. 550 ppi, so pixels per inch. So that's basically places where we can have no color and yet in another spot have color. So in this case, obviously we could have color missing more than we could not have color, but the idea is we want to be able to, where we have color in one line, we need to be able to step over 5,000, right? So this is 550, while here we could have basically 40,000, right? 40,000 pixels per, so this is 550 pixels per inch. So basically, let's open another calc, and if we have this guy, let's say, which is their highest, yep. So we have 3040 times 1440 equals 4,337, 6, yeah. And then this one, so millimeters to inches. So then we have I'm gonna just say that it's this 150. Obviously it looks less. Actually, let's do 20 millimeters. Let's say 145. 145 is 5.70866 times, and I'll explain why I'm doing this in a second, times 70, let's just say, which is 2.75591 equals. That's 15 square inches. So now we have pixels per square inch, 533,537,600 divided by 15.73255. It's approximately 278,000. So I guess technically what I could have done is theoretically it should be pixels per inch, so 550 times 550. So let's see what that is. 550 times 550. 302. Yeah, so a little bit under. So I might have taken too much off for the chin. But yeah, so that is about 6. That's about, so we have 40,000. 7.5625. So let's see one more thing. If the steppers will be able to make it work, what resolution will we have? So obviously we had this one, and this is 9.4. No, I'll just do it the other old-fashioned way. This is 9.4 divided by 25.4 equals times 3.14. Okay, so that's 1.162, right? We already know that. And here we have this encoder here. So let's say that this is divided by 8,192. Oh, we do already have that. So that's 1/10. So basically the smallest, I don't know why we redid that, but now you could see that. So that's 0.0001485. So that's 1/10 of a thousandth. 1.5 tenths of a thousandth, right? And the beam that my buddy has is 5 thou focused. So basically 5 thou 0.005 divided by 0.001485 equals, it's about 33 times smaller than that. The steps that we could take with this drive. So what I'm thinking is that we are, and we'll have way more torque with this motor than the other option. So I'm thinking we can go with O-drive. We're going to have plenty of precision. We are 33 times more precise than we need to be, but what that also means is that we could drop the laser size. And basically what I really like about this is that we could set in the controller, we could set the, if we didn't use that controller and we use an open source controller, we could set the tool diameter to whatever we want, right? And basically that would be the laser diameter. So we could find something that maybe is like 2 thou or something, 2 thou laser thickness, and then have it do the step over that it needs for that 2 thou laser thickness. So that would be really, really nice. So I think O-drive is probably what I would suggest, that what I'm going to use just to get the speed for the rastering. Obviously the speed for the what is it? The speed for the vector and cutting, I don't really, you're not going to see much improvement with the O-drive, but for rastering it's going to be a big difference. Now, is it needed on the Y? Probably not, but here it's definitely going to be needed. So yeah. So anyways, thank you guys for watching this second video, and I will see you guys in the next one. I'll try to catch up by doing more of these videos, and I'm actually probably going to have next week off of work, so I'll probably be catching up by doing a lot of these videos. So thanks for watching. Take it easy.